So last time we talked about this data storage scheme that I want to change the data storage scheme to make it take up less disk space and also have a faster rebuild time. I'm in the process of doing that. I'm a little bit of the way in doing that. So far, I'm not getting great disk savings from what I see, but I don't know. I still wanna. I think the problem is okay. I'll show you a little bit of what the files look like. Okay, so there's a value table. Previously, there was an object table, but now there's a value table, and then there's a member table. Member table is for storing entries of a dictionary or entries of an array. Those are called members, and they point to the container object, which is an ID to a value, and there's a key. And the key is also pointing to an entry in the value. And then the value is also pointing to an entry in the value. And then there's a version, the state version number, and whether it's been deleted. So if you want to delete an entry, you have to put another entry in here and say it's deleted. But I actually haven't implemented that yet. And the value is all the values of the system. Strings can go in here, but numbers can go in here as well. So that's a string, that's a number. And so far, it only works with very simple programs, such as the Fibonacci. I also had Marty write, I've been teaching Marty recursion. And he wrote this one.
Nice.
It's pretty good. It calculates the greatest common divisor of two numbers using this recursive algorithm. This is the Euclid's algorithm for GCD. You can run the debugger for something like this. So it's the same Python that I'm using. I haven't changed the log format. So the version of Python doesn't have to change. It's just the recreation script that changed. So if I run it, it still spits out the same type of log file, but I have a new recreate script called recreate2. And I give it the same log file as before, and it generates a database, and it looks like the one you're looking at right now. Okay, so that's the sort of the update on that.
So does the value table only store primitive value, or what if?
Yes, only store primitive value. If it's a composite data structure like dict and list, then you have to use the member table to add entries to the object.
Okay, gotcha. I see.
Yeah, so exactly. The values are only primitive data, or it could be like just if there's a dictionary, there is still going to be a row in the value table that represents that dictionary, just for the members to link to it, but the data won't actually be in there.
Gotcha, I see.
Although even that could potentially be eliminated, but I thought still put it in there. Because if you have the members in there, that implies the existence of the container. I don't know. But it seems a little weird that there's some values that are not in the value table, you know? So in terms of disk space, I just want to show that. So I did the GCD. Okay. So this is the log file that was generated when I run the program. It's 3 kilobytes. And the generated file by my new recreate process is 45 kilobytes. That's substantially more than the log file, which was disappointing. And it's also more than the previous version. Okay, that's also disappointing.
Why would be more?
Why could it be more? I can theorize. I think it's that the amount of sort of amount of data that, like, I have this type data that's kind of duplicated. Like one means integer, for example. And I also have these ID data that we are gonna need to put. There's just more disk usage up front, with the promise of in the long run, it'll get better if you have even more data. So that's a case of the Fibonacci one, where the old one took 1.1 megabytes, but the new one took 94 kilobytes. That's only a little bit better, but I don't know.
Okay.
So that's where we are, but I haven't tested it on really some of the program I was testing yet. So I'll just keep working on this until it's in shape to test those larger programs.
Okay.
And then I'll think about what to do next. So this scheme, okay, I'm not seeing immediate gains, but maybe we'll see. Maybe we'll see gain for very large programs. I'm not sure, but in any case, this is an experimental approach. So we're just gonna try it and see what happens. Another thing I was thinking about is visualizations. So last week we talked about visualizations, and that got me thinking. Like, how can I get ideas about visualization? So I went to the D3JS website and looked at all their examples.
Okay.
And another thing I did was I asked some questions about, like, actually I would like to do this brainstorming with you about what kind of visualizations could potentially be good. But so we're gonna do that. So basically, I looked through all of the examples they had. Like, oh, look at these tree ones; they look really cool.
Okay.
Like, whoa, that looks cool. There's some that look really cool. This is a sunburst graph. I think this is called the Nightingale chart, if I'm not mistaken. Okay.
Oh, wow.
But actually, one that I decided to use is pretty ordinary. Like, I decided to try this one, which is very ordinary. So remember last week you said, like, when I was zooming into Google Earth, you said this is just a tree structure, right?
Yes.
So I decided to try that. I saw this and I connected to what you were saying. I decided to try the tree structure. Basically, the zoom visualization that I did before, I did the same thing, except that it's a tree now.
Okay.
So I run the program, and then I used the new recreator to recreate the database, and I wrote this C code script. Okay, so this calculates the Fibonacci of number of 10, and
Nice.
And you can see what it does in this tree form. So you can kind of see. I showed this to my son, and I actually just taught him about recursion and using the Fibonacci as the example, so he knows what's going on here. And I can show him, well, if you do this the naive recursive way, this is what's going to happen. And you can see it's actually doing a ton of work. And if you dig into it, you can see where the duplicate work is happening. Like, for example, like, why am I doing this fib4 and then 4 3 2 1 here, and then I have 4, 3, 2, 1 again over here, and then I have 4, 3, 2, 1. Like there's a ton of duplicate work here, right? Like 4, 3, 2, 1. I have 3, 2, 1 here. I'm doing 4, 3, 2, 1 here again. 4, 3, 2, 1 here again. And another thing he saw was like, okay, this takes 343 steps to do this program. He called it lines of code. He called it like 443 lines of code, which is not what we think of as lines of code, but in this visualization, it is lines of code. It was the lines of code that was executed. And then I showed him, yeah, and I showed him with the table, basically dynamic programming, right? We just memorize.
Oh yeah.
Yeah. So if so I showed him what would happen if I use a table to memorize the values, and this is what you would see. This is what you would see. And first of all, he sees that, oh, there's 92 lines of code instead of 400 something, instead of 400, and then you can see the sort of this structure, the shape of the thing, the coastline is different, and it goes indents all the way to the end, and then it gradually comes back down, and obviously there's less work to do because of the memorization, and there's no duplicate work anymore, and you can see the returning from the table happening in these places, right? So yeah, so I actually think this is pretty cool result. There's the loop version also, obviously. When you do Fibonacci, you have to do the loop version also. So if you try the loop,
what do you call?
This is the loop version. Yeah. Hello. You're muted.
Oh, I'm back. Well,
okay.
I was lost. Well, because of the internet.
Okay.
So.
No worries. What were you gonna ask?
What was the lines of code? Was that like the stack frame, or like what exactly that was that?
It's the number of snapshots we have in the database, which corresponds to conceptually, actually, it can correspond to the number of instructions that were performed by the computer. But it's not exactly that, because you can have some lines of code that have cause multiple instructions to occur on the same line. So basically, it's the number of lines in your Python program that were executed in total.
Okay. Okay, that makes sense.
In Python tutor, they call that step. How many steps?
Okay, that makes sense.
Yeah. So it's a rough equivalent to the amount of work your program had to do.
Gotcha.
Which is, I think, is very helpful for like CS classes, right? When you're talking about algorithm complexity. Right, because then you can just look at this number at the bottom to see how much work the program had to do.
But it just have the time complexity, it doesn't have the space complexity.
Right.
Because if in programming, you can use the space to memorize the stuff, but that doesn't show.
Yeah. In a way, though, this you can see the space complexity that is used by the stack, because that's how far to the right the text grows.
Okay.
Like the more stacks you use, the more to indent it to the right it goes. So you can sort of visually see how much stack space you use. But then there's, other than stack space, like like this one, it doesn't use any stack space at all. It's just a loop. So it uses less memory than this one does. But of course, other than stack space, there's still dynamic object space, and that uses memory also. So that's kind of the open question for me. Like that's a question I really want to tackle is, first of all, like what do you think about this visualization here?
Well, I like it. Well, if we can collapse, that's even better. But I like it. I think it's very helpful. For example, with this, we can have the information of, okay, this program does some repetitive stuff. So we can actually see the big picture. But I mean, I like it. I like how simple that is. Oh well, if it can be collapsed, that's even better. But
yeah. I mean, yeah, making it collapsible, definitely doable. Yeah, we can do that. And you worked on some code that does that, so we can probably use that. What is going on with my terminal here? It's kind of going crazy. That's all right. So the thing I would like to do is some brainstorming around with you. So perhaps what we do is I'm gonna make a Google Doc. So there's a couple of ways I think we can try to come up with ideas on how to do visualization. One way is just look through all of these examples of data visualization on the D3 website.
Okay.
And if you know of other libraries that do maybe like high charts or something, or maybe other, there's Obama's face. That's a visualization. Okay, so anything, sometimes just by looking at something, you get an idea. Another way is we can ask, so the question I want to ask you now is like, what are the most common questions that developers ask when they're debugging a program?
Okay.
Okay, give me some ideas. So we're just gonna write some sort of examples.
Common question. Like, how many times is this line executed?
Yeah.
Well, or yeah, that's a good question.
How many times was this line?
What is the value?
What is the what?
What is the value? What is the value of a variable when this line get executed?
Yeah, on this line. Yep.
Yeah.
Yeah. Was this variable null? And that's similar to what is the value of this variable? Like was.
Who calls this function? Like, what is the parent stack that calls the function?
Yeah. Who called this function? Who called this function? Right. Yeah. Exactly. That's a very or what? How did this data get there? Get here? How did this data get here? How did this?
When was this object mutated?
When was this object mutated? Oh, at work I was debugging a problem with Johnny. Like it took us hours to debug various problems. So one of them was like we had this constant called the empty object or something. It was more than just the empty object. It was like the, a dictionary with some children, but each of the children were empty objects, right? It's a collection of dictionaries, right? It was the empty version of what it means to be empty for that situation. And there was the constant because it was, we were planning to use it for whenever, we wanted an empty version of the object, and then we were gonna do a reduce over it. to calculate the value, starting from that as the empty value, right?
Okay.
So what happened was the reduce function that tried to, accumulate values into it actually mutated the empty object, the empty version. So then the second time, the empty object actually had values in it.
Okay. Yeah, that happens.
That happens. Yeah, I did that in my debugger too one time. I did that exact same thing.
Yeah.
Okay. So what other questions would a developer ask?
What other questions? Sometimes they just want to examine an object that is very deep. It's like, how deep is this object? How does, like say if it's an object with a lot of items, they just want to see maybe one of the items, like the first one or the one with that value or something like that. Just want to look at a big object.
Okay. What does this? What's in this object?
Yeah, exactly.
What's inside this object?
Yeah.
One, like, the more difficult bugs or things that developers sometimes diagnose is like performance and memory leaks, right? So when they're dealing with that, but the performance is like, is this function slow?
Yeah.
It is the sort of most lazy way of asking that. Is this function slow, or maybe what function is slow?
Why is it slow?
Why is it slow, or why is it slow? Or what part maybe which part, why is it slow?
And also
Mhm.
when there's like asynchronous situation, it's like when this function is executing or doing some async stuff, what are the other stuff that's happening at the same time?
Okay, what other things are happening while this is happening?
Yeah.
Is it, or like, is there a race condition?
Right. Oh, whether we are in an infinite
are
or
we
something.
or another way to ask the is there a race condition question is like this, did that happen before this?
Yeah.
Did that happen before this, or which one happened first? Which one happened first? Okay, the infinite loop. What about the infinite loop?
Like are we in an infinite loop?
Like
how do we get?
like when the program just freezes. Okay, do we have an infinite loop? Okay. Yep. Yeah, sometimes you don't know. Like the program freezes. Sometimes it could be it's freezing just because some part is really slow. Do we have an infinite loop? That's an interesting. I don't see a obvious answer to that. You're gonna an infinite loop, I'm somewhat worried about because it's gonna generate so much log. Yeah, so we'll see. Okay, let's start with these. So for each one of these, try to come up with a visual that could help answer that question. How many times was this line executed? How would you make a visual to answer that question?
So this is like line related. Can you like hover over the line number and then you will get some like a little pop-up saying this line was executed 5 times in my log? Or
Yeah, or just you can even do it just in the gutter of the line. Just show a number there.
yeah.
Hover over line or show the number in gutter. Yep. How many times was this? Who called this function?
Yeah.
Okay.
So in this case, in the Fibonacci program that you wrote, say the fib equal to 3 or whatever, it's going to have like saying, oh, it's executed by like 10 times or whatever. And then you're like, oh, maybe that is what the problem is, something like that.
Oh yeah. It'll say it's the not the number you expected.
Right.
My terminal is completely dead. Okay, I can't get it to work. Do I have a different terminal? Do I have Xterm or something? Oh, my computer is really going crazy right now. Okay, I'm just gonna ignore that. What was the value of this variable on this line? That's
Hover over the variable.
to see the value.
Well, that needs to be done with a stopping point, right? Because if this line is executed multiple times, then you need to.
That's actually the thing that I want to challenge. Because one thing unfortunately I can't show you that tree visual again. But one thing to realize about that visual is that that's a timeline.
Okay.
Right? It's the first line of that visual is what happened at time number 1, and the second time, and the last line is what happened at the last timestamp. So that's actually a timeline, and which means that the user interface does not have to be we step line by line through the program state. There's no single stepping anymore, because what we've done is we map time to space. We map time to a timeline, which is just one dimension on the screen, right?
Okay.
And I think that's actually a very powerful concept that we can use to. I think like that visual of the tree, there's no user interface to it, and yet it has everything you need to debug that Fibonacci program. So there's no need to interact with the thing other than scrolling and being able to see. If you just printed that out on paper and the paper was big enough to have all the text on it, then just looking at that is enough to debug that program, right?
Well, that is true, but I guess the question we're trying to resolve is when there's too much information, how can we make a human like try to find out what exactly is he interested in the huge amount of information?
Yes, but I think there might be a way to do it with a timeline based visualization. So if we try to map this question to some sort of timeline based visualization, that could just be, you can hover over a variable to see the value. That still works here because on a single line in this visualization, that's actually one point in time. So there's actually no ambiguity if you do it
Okay.
on this tree-based visualization.
Oh, gotcha. Well, then the developer has to have a mental map between the original code to the snapshot code or lines.
Yeah,
So
that's
he
true.
needs to understand what exactly the relationship is first.
Yeah.
Yeah.
I think that that part is gonna be different from what people are used to, and
Uh-huh.
you know, if you know, that's yeah, it could potentially be either we just get them to do things that are very different from what they were doing, or we come closer to them in some way. I don't know. This is a research project, right? So
Gotcha.
hover over the variable to see the value. So if it's a step debugger, then I imagine if the tree visual, then no ambiguity.
Mm-hmm.
If it's a step debugger, if step debugger it's fine too, because there's an implied current state at any point in time.
Right.
So based on the current time.
Mm-hmm. Is it possible for it to just print a list of values? Say
Yes.
this line is executed 5 times, and then let me give you a list of how this value is,
Yeah.
like an array of 5 things.
Show all historical values of this variable.
Yeah.
Yes, you could do that. And I think Bill Lewis's database, or ODB, sorry, ODB, he can have given given a variable anywhere in the program, it can show you all the historical values of that variable, and then you can click on each historical value, and then it'll jump to the place where it was set to that value.
Mm-hmm.
Jump
That would
back,
be,
yeah, jump back in time
yeah,
where it got that value. So
yeah, that, yeah.
jump, click on one and jump back to source of the value. That would be cool. Another thought I had about, like, if we have this timeline based visualization, like the tree, is
Mm-hmm.
you could ask what are the historical values of a certain either variable or an entry of a dictionary or something,
Mm-hmm.
and it can plot that on the timeline. Because if you can imagine, like, your code is like this, maybe.
Mm-hmm.
Your code is like this, and if I were to say, hey, I have a dict somewhere, dict 1, and I want to see the historical values of dict 1. Well, I might have this, maybe in this point in time there was a change, and then in this point in time there was another change, and in this point in time there was another change, and then there's another one. So
Uh-huh.
this plot here on the right is kind of like the lifetime of this dictionary,
Mm-hmm.
and maybe you can, I don't know exactly how to visualize this. Maybe maybe if the dictionary is small, then you can show the full dictionary on the timeline. But obviously, if the dictionary is big, then we would have to think of something.
Oh, you reminds me of the object compare library that you wrote. You can just say, if you compare this object to that object, there are 3 entries added or 3 entries removed or whatever.
So you're saying we could also show the diff. Is that what you're saying?
Yes.
So you're saying like at this point in time here, and then at this point in time, it's like we added the key of A. We added that one.
Yeah.
Maybe that's not the. It's like Git kind of.
Yeah, exactly.
And then we added A, and here we modified A to 2, etc. So you can kind of see a summary of the lifetime of this dictionary.
Yeah,
yes.
exactly.
Yeah, that kind of thing, yeah, is what I'm thinking. It could, obviously this is, to get this to work really well, it's kind of a challenge, but we should think about something like this. So yeah, maybe use it. Oh, okay. I don't know if that's a great, maybe I should do, I'll just do a screenshot. What just happened?
I think something weird on the screen.
Oh, my computer is just severely, okay. My computer's display is just really broken right now. That's okay. Oh,
okay.
We might have to log out, log back in at some point. Okay, what time is it? I suspect my clock is off too.
It's 10:19.
Yeah, it says 9:57 on mine. Okay, all right, 10:19. Okay, so yeah, this is show all historical. Like another idea is, this diff idea I think could work pretty well, maybe.
Yeah, I think if we can give both information of how the object looks each time, if they want to see it, but it doesn't have to be expanded. And then we can also give, that would be great.
I mean, they could definitely, I could just see, like, it's easy to let them ask for it. That part is easy. Like, we could also always allow them to click on the line and then let them see the entire world of objects as they are during that point in time, right? That's easy to do.
Yeah.
If you already fixed a point in time, it's easy to, it's just like, we're just gonna let you see all the objects, what they look like at that point in time. But it's across a time, trying to plot it on a timeline, it's more challenging.
Yeah.
So yeah, so an idea is maybe look at some time-based visualizations, which might be like these scatter plots.
Whoa. Whoa.
Scatter plot, or like, well, obviously there's histograms. Histograms we could use for, like, if you have a integer value, we can make a histogram of the integer value, or we could make a histogram of the size of a dictionary or size of an array, like this.
Okay, that's cool. Yeah.
And then maybe we could also do like an area plot like this. Sure. Like I can see this being used for memory usage, like maybe each color is a different type of object in the application. How, like, what objects are responsible for taking up the memory? You can kind of see this.
Yeah.
And I think the concept of a lifetime of an object, a lifetime chart of an object, can be really powerful. But which question does it answer for us?
The value of the variable.
What value? What is the value of this variable? on this line.
Right.
If we already know the line, we don't have to go for the timeline thing.
Well, the line, by the line, I mean the line of code, I guess.
Oh, I see. When
Yeah.
it's a line of code, but I see. And yeah, in that case, yeah, I can see if you click on, like, you click on this line, this line actually could map to this line and this line.
Mhm.
It maps to different lines on the actual execution. So
Yeah.
so maybe you also have a panel that's your actual source code, and then you're clicking on lines on the actual source code, and then it highlights the lines of execution in the
Yeah,
thread.
it can also answer the question of when is this object mutated?
By when was this object? How? By clicking on the line that's mutating it?
Yeah, or if you can see the lifetime of the object, you can click on,
Yep.
say,
Yeah,
whichever
if you just
line.
see the lifetime of the object, it's each time that this happens.
Right, so you know which line mutate this
Yeah,
object.
and if it's an int, or if it's a string one, maybe strings don't mutate, so there's that. But but there could be a variable string var one. Maybe at one point it was a, and then at the next point is ab,
Right.
and then at the next point is abc,
Yeah,
something like that.
exactly.
And then you can see the different points in time where that mutated.
Yeah.
How did this data get here? That's maybe like it's like a backtracking thing. I don't know if that's something. Can you think of a visual that would do that, to figure out, like if I had like if I see, I guess if it's a string variable, like at some point it became blark.
Okay.
And then you're like, yeah, that's wrong. I think you just click on it, and then it jumps you back in time to the assignment, and then
Right.
you get to see the assignment.
Yeah. So that's the same as the mutation thing.
Yeah,
It's
yeah,
just
yeah. If
like
it was an array, then like if you get a weird, like your array is supposed to look like this, and then later on you get a weird thing get inserted into array. If we do the diff thing, this would be like, we added at index 2, we added 3.
Yeah.
Or maybe like, yeah, maybe we write it like that. And then this is like at index 3, we added arc. And then, and I can click on this and get to the line that made that assignment.
Yeah, exactly.
Yeah, that would be cool. That would be cool. Yeah, this diff idea is pretty cool. I really like that. Showing the diff. Because another thing you can do with the diff is, remember in the zoom visualization where I'm like hiding all the details within the subtree, basically. So it was like, I have a hero, I have a hero, I have a monster, and then they do battle.
Okay.
Like I have a do battle, and then what I did with the Zoom visualization is I actually print out next to this the aftermath of what happened in the battle. And then, but the way I did it was I just printed the full state of the hero and the full state of the monster, because something within them have changed. But with the diff idea, what I could do is, I could say hero.health is equal to 7 now. That was the update. And the monster.health is now -4.
Okay.
So these are like the updates. Should we put like this plus sign just to make it look like a diff maybe? So like this is the change from the previous line before do battle happened. So we could do this like this, and then if you're wondering how that happened, then you can do a drill down on do battle.
Yeah, I think that will be very helpful.